primary control with critical vehicle function.
Welcome to Future Thinking episode 70. Today's topic is Future of Farming. Farming is a bedrock of our society and culture, and at the same time one of the largest contributors to environmental degradation. So how to feed the population of the world in the future sustainably is a subject I wanted to cover already for some time. But it was important for me to find an expert who can bring together theoretical knowledge and real business application experience. I'm very happy today that Padraic Flood agreed to join me for this conversation. He's currently team lead for crop genetics at Infarm, a vertical farming company. Before he joined Infarm, Padraic served as a research scientist at Wageningen University, one of the world's top agricultural research institutions, where he also completed his Ph.D. Before that, he held an appointment at the Max Planck Institute for plant breeding research. Over the past decade, Padraic has worked in universities using genetics to understand key scientific questions ranging from photosynthesis to how plants adapt to extreme environments. He's not only an excellent scientist, but deeply passionate about tackling the challenge of feeding the world without destroying the environment. In addition to breeding and improving crops currently cultivated by Infarm, he is pursuing ways to make staple crops viable in indoor farming, which, if successful, could free up vast areas of land for nature and biodiversity restoration and go a long way towards achieving food security. Now, without further ado, my conversation with Dr. Padraic Flood. Good morning, Padraic. Thank you very much for joining this discussion with me.
Morning, Alex. Thanks for having me.
So I would like to start our topic about farming, future of farming, with the opposite, with a look to the history of farming, and maybe you can give us some ideas what the origins of our today's farming is, and also maybe why we could say that farming is one of the origins or also founding principles of modern life.
Yeah, sure. I suppose you can say that, right? Farming and agriculture is the keystone of civilization. It's the bedrock. It's described by some as probably the most significant innovation in the past 12,000 years, depending on exactly when you decide farming really began. Farming and the associated practices of crop and animal domestication. Prior to that, modern humans have existed for probably a couple 100,000 years with relatively little technological advancement. And once farming came, that not so long after that, a few thousand years, there were already cities, the Sumerians and others. And the funny thing about it is, in many respects, up until very recently, the farming that was started, 10,000 years ago, hasn't really changed significantly. We still do it in fields. We still grow annual crops. We require clearances of land. And when our population was much smaller and our footprint as a civilization was much smaller, this was okay. But of course, now we're at 8 billion people, and continuing to farm like this is just not sustainable. It's the main source of environmental degradation globally. And as a result, we need to think carefully about how will we feed ourselves in the future. Otherwise, there might not be a future, at least not one for civilization as we know it.
Before we come to these very important questions of what impact farming has on the planet at the moment and potentially in the future, maybe could we talk a little bit about what domestication and breeding actually means and what
Sure.
changed there? Or what did we as humans change when we started domestication and breeding?
So let's say domestication is the outcome of breeding. We can put it like that. And this is probably the very first species that we really domesticated was the dog. And that happened prior to farming because we lived very closely with wolves for a very long time. But once we came to farming, we needed to domesticate species for food production, in particular, plants and livestock. What is really special about domestication and the process of breeding is that it gives us a control over the substance of life, which is evolution in a way. So it allows us to change living organisms and therefore have access to the potential of that. So if you look at modern crops in particular, like for example, maize is a really good example, and you look at the wild species that gave rise to it, they're unrecognizable. They're completely different. And this was work that was undertaken by early farmers thousands of years ago, where they found plants that looked different, saw the value in them, and selected them. And this was an intergenerational project. I'm not sure that anybody had a clear vision on where this was going, but it was something that happened in an iterative fashion where, at least that's how we understand it today, where people saw this plant is growing a bit better, let's keep the seeds of that. And across, farming was, or agriculture was independently discovered about 7 times around the world. And in many cases, we focused on grasses, grains. And the same kind of traits were selected for multiple times independently in these grasses. For example, non-shattering seeds, which makes a lot of sense because that means the seeds, when you collect the grain, they don't fall all over the place. You can harvest the grain, you can bring it home, and you can process it. And this happened in barley, in wheat, and so on and so forth. This ultimately is the result of genetic changes, which we select for. So instead of just natural selection operating on living organisms, suddenly there's artificial selection mediated by humans. And that ultimately gives rise to what we know as domestication.
What you said is fascinating in at least two dimensions that just come to my mind. The one is, I didn't know that you said about 7 times this way of selecting crops developed independently. It's just incidentally an interesting point, because when you look at the evolution of biological life, for instance, things like the eye or other features that we know in different animals, I think the eye occurred in evolution 4 or 5 times, I don't know, something like that, in separate strains. So this was not one incident where it happened, but it seems to be such a such a prominent advantage that it happened more than once, right? And I just find it interesting that the same happened with farming. I didn't know that.
Yeah, this thing that you talk about, this is what is known as convergent evolution. And prior to moving to the private sector, when I was still in academia, this was one of the topics that I studied in plants. And it's a very interesting one because even in natural systems, natural species, you see it occurring a lot. The eye is an example, but you also see it in plants for morphological traits. And it raises a very interesting question, which is one that has been debated by scientists for a long time, which is the relative role of determinism versus contingency in living organisms. And this applies at all levels. And it's not exactly a resolved question. It seems to be that the relative role of one versus the other depends on the starting point, which isn't very surprising, because the more different the starting point is, the larger the role of contingency will be in evolutionary outcomes. And that also then applies for crops. As you can imagine, the kind of things that are selected for in a tuber crop are very different than the kind of things that are selected for in a grain crop. There are some commonalities: yield improvement, maybe more starch, easier to digest, better flavors, things like that. But you don't get a non-shattering trait in a tuber crop because that's just not relevant.
Very fascinating. Just because we have a lot of other topics to discuss, I don't want to dive deeper into the evolutionary topic, but maybe for the audience, recorded one long episode with Erich Eder about evolution. So if you're interested, you find the link in the show notes about the whole evolutionary topics. But maybe you said another thing that I found very interesting. You said how little the domesticated crops, for instance, had in common with the wild form of the crops. And if I would say something, as a layman, because we often talk about what is natural, what is organic, and these things. Now, my layman's perspective, when I look at the stuff that we eat in terms of crops, but also animals, my feeling is hardly anything we eat today would justify the term natural in any original sense, right? Because nothing of that has anything to do with the wild forms, or am I wrong here?
Yeah, I mean, it becomes somewhat an interesting debate, which is a little bit philosophical, a little bit semantic. What is natural? What is unnatural? Broadly speaking, I think the general understanding is unnatural is something that was created by humans. But I find this to be a strange dichotomy, because then it assumes that humans are somehow separate from nature. And I don't really know the origins of this. maybe it's a Christian theology or perspective on things, that we are somehow special and separate. Personally, I don't find that the dichotomy of natural versus unnatural has value. I actually think it causes more damage than it helps. I think man-made versus unman-made is clear, and it doesn't have this sort of ethical connotations that natural versus unnatural has, because unnatural is usually considered bad, and I don't think that is necessarily the case. There are many natural things that are, I think, objectively bad, certainly from a human perspective. There are many diseases, and there are many unnatural things like this computer that we're using to communicate, which can be very good. So that's this good, bad, unnatural versus natural is not really useful. And when it comes to our food, I think it holds us back a lot, because yes, as you said, these domesticated forms are very different in many cases from their wild ancestors. So much so that it actually took us a long time, in some cases, to discover the wild ancestors, because it was so different. We didn't even know what species they came from. And it took a lot of research, and even in some cases, modern tools of genome sequencing in order to identify the wild progenitors of some of our domesticated species. And as we move forward and we try to create even more sustainable food supply and even better food supply, thinking of like hypoallergenic bread, for example, these are things we could do, but to do them in a reasonable time frame, we need to use the most modern technologies we have, for example, biotechnology. And this brings us into the domain of genetically modified organisms, which are basically what we have been doing in many respects for thousands of years with domestication and breeding, but just a much more precise and refined form of this, where we have even additional control. But because of this perceived unnaturalness of it, a lot of people, especially, for example, in Europe, have a knee-jerk reaction to it, and they don't want it. And although there are pros and cons, like with any technology, it certainly has a role to play, in my opinion, in a more sustainable food production system of the future. It allows us to do things which are not really feasible with conventional methods, but we're not using this technology because, in many cases, of this perspective rooted in this natural versus unnatural dichotomy.
I think there's a very good and very interesting point you made, so the philosophical point about what natural means. I think that's actually very helpful to think about that, because we hear it often in like activism or like in advertisement, like where this natural thing is referred to, and then often it's not given a second thought, what does it actually mean? And I like what you said with man-made, because why would human suddenly be something unnatural per se? This is sort of a weird idea, in my opinion, too, at least. And what you said, man-made versus non-man-made, at least is neutral in that sense. And so if I understand you correctly, at least we could say that the majority of the staple foods and also animals that we need as food today is certainly not as it was like 15,000 years ago. It is certainly mostly man-made in a wider sense. I think this is correct, right?
Yeah, I mean, certainly if you look at our livestock and our crops, they're significantly different from their wild ancestors. And a lot of those differences are driven by the actions of man, or of humans, I should say.
And the reference you made to modern breeding practices, I would like to pause for a moment, because we come to that a little bit later when we talk about what modern technologies we have to, bring farming forwards. But let's maybe now go from the distant past. You said like 15,000 years. Let's go towards the 20th century maybe, because maybe just as a reference for our listeners, in the 19th century, the human population reached something of about 1 billion people. This was in the 19th century. And before the 19th century, it was actually very flat, so maybe under 500 million globally. And then it started to rise rather significantly after Industrial Revolution. And we had about 1 billion, I think roughly 1850 or something like that. And then the enormous development in the 20th century was that from the 2nd billion to the 7th billion human, or population size to be precise, occurred in the 20th century. So we had an unprecedented growth in human population. Now, this led to some, interesting developments. I think on the one hand, we had people who were very fatalistic in the sense that we would a large part of humanity would starve. And maybe you can talk a little bit about that. What was the perspective here, maybe like in the 50s and 60s, and what happened then with our capability to what we call the Green Revolution, maybe later on.
Sure. So if we go back to the 19th century, and even a bit before, perspectives on this kind of started with Thomas Malthus, where he basically said, look, crop improvement has this linear improvement rate, and then human population can basically become exponential, which to some extent happened. And he said there's going to be a split between the two. Human population will outstrip food production, and you will have some mechanism which then controls human population, famine, war, disease, whatever, these so-called Malthusian disasters. And as a species and a civilization, we've been really successful at preventing this on a large scale. I mean, there have been tragic famines in the last 100 years, of course, when this has failed, but by and large, we have succeeded. But by the 1950s, as you mentioned, the population had gone from under 1 billion to 2.5 billion or something like that in less than a century. And people thought, oh my God, they referred to it as the population bomb. There were books written on this by Paul Ehrlich and others. And the perspective really was that we were heading for a disaster, and we needed to do something about it. And the only solution ultimately was some sort of control on population. But as we know today, and the fact that myself and yourself are alive and sitting here, they were wrong. And the reason they were wrong is that not everybody was so fatalistic, as you put it. And there were others like Norman Borlaug and people like that tried to improve our food production such that not only would there not be famines, but rather there would be an abundance of food. And they were incredibly successful with this. Now, this didn't come, of course, without costs. There were environmental costs associated with this. But it certainly, if you look at least from my perspective, the options that we had at that time, there was global famine or there was environmental degradation, basically. Although I don't think they really thought of it in those terms at the time. I don't think it was so clear cut. I mean, looking back, we see that now. And of course, they chose to prevent global famine, because what would you do? Now, the population has continued to grow, and most demographers will tell you that we've passed peak child, as they call it, the steepest point on the exponential curve. And our population is expected to level off in the next few decades and more or less slow down and stop growing. And that has already happened in some parts of the world. So the way I look at this is we need to somehow provide the technology and the food supply so that we can reach that peak without destroying the planet, without destroying our habitat, and without destroying the well-being of future generations. And the only way I can see of us doing this without massive numbers of people starving is through technological advancement, particularly food production. The way I view this food production, a lot of the people say, oh, we're just offsetting the problem for another day, right? I mean, they didn't have the population bomb in the 1950s, but, you know, the clock kept ticking, the population kept growing. It's going to come. The Malthusian disaster will come. It's going to happen. And there are doomsayers at every moment during that period up until today. And they continue to say that. And many people are worried about that. But what this technology does is it buys us time. Now, I don't think we've necessarily always used that time very wisely. And that's, of course, a complicated discussion, which is a little bit outside of maybe the topic of today. How should we use our time as a global society? But if we can get to that peak and still be in an okay place, and if we can do that using all the technologies that we have, that population peak, then I think there's hope. Because then the population will level off and it will gradually decline, or at least that's what we expect to see in the coming decades. And that's how I view this, and that's what gives me hope for optimism from this side, is that I do believe we have the technology. Whether we will use it, whether we will implement it, and whether we will have the kind of effective governance that we need to truly use that is still an open question. But I am obviously working in this space and trying to contribute towards this. Yeah. And I think there's a chance. I think there's a chance that we can actually succeed with this and prevent this so-called population bomb from ever exploding.
Yeah, my gut feeling is also rather optimistic at the moment, especially considering, as you mentioned, the change in the population dynamics. But maybe before we come to the next question, just because you mentioned Norman Borlaug too, it's actually quite interesting when you read his Nobel speech. I will also link that in the show notes. He mentions also the two sides. So he on the one, because Norman Borlaug received the Nobel Peace Prize for his achievements, and he mentions on the one hand, as you said, like how dramatically food production could be improved, and like hundreds of millions of people probably were saved from starving. But he also mentioned that, as you said, we bought time, and we also have to think about the population issue, because I think Borlaug himself was not convinced that we could continue with that indefinitely in a such growing population scenario. But this is a disputed question. I think we're going to come to the questions, what type of impacts does farming have? I think that's maybe the next logical question we should pose. But maybe let me just... please.
Just
please
one comment that certainly what's certainly true, right, is that the planet is finite. So there is an upper limit, no matter how good our technology is, to how many people can actually live on the planet. I don't think we know for sure what that upper limit is, because we don't know for sure what kind of technological advances we're capable of, and so on and so forth. But that is an academic question. I think we do know that the population will level out. The analysis I've seen is they expect it will go no more than 11 billion, and then it will start to decline. Can we survive with 11 billion on the planet? I think we can. I don't think it's going to be easy, and I think it will require us to get organized and to use those technologies. And of course, when Borlaug made his speech, we were at a different point on this population curve. And it wasn't entirely clear where this was going to level off. I mean, it's still not completely clear, but we have a much better view on things than we did back then. So I think looking at the dynamics of this, I think we have a chance.
And by the way, there are quite different suggestions on how this development will be, because there is the UN prognosis that goes somewhere in the direction 10, 11 billion. But there are also others. For instance, I saw Lancet had a different scenario, and they think it will be a bit lower, rather towards 9 billion. So again, this is different models, different scenarios. I might also link those pages in the show notes. So if you're interested as a listener, you can follow that up.
And lower is better, right?
Yeah.
I mean, if Lancet is projecting lower, I mean, it's certainly from a planetary perspective, it's better.
I would just like, before we come now to the question, what are the impacts of farming actually? Because that's also important to understand, I think, to get a better idea of what we should do in the future or avoid in the future.
Sure. So
wait. Give me 1 second, because I would like to make one quotation. Because I just read, I don't know if you know the book from Václav Smil, How the World Really Works. And I haven't read it,
but I've heard of it, yes.
No, it's an amazing book, I think. And I just would like to quote 1 or 2 numbers from his book, because he has a whole chapter about farming, and also see if you agree with that. He made, for instance, the example of how much human labor was required, and in that sense also energy, to produce a kilo of wheat, and which reflects roughly 2 loaves of bread. And in 1800, he writes about 10 minutes of human labor was required to produce this amount of this 1 kilo and these 2 loaves of bread. In 1901, so roughly 100 years later, it was 1.5 minutes of human labor. So from 10 minutes to 1.5 minutes, plus 2 minutes of horse labor. And in 2021, it's smaller than 2 seconds of human labor. So we have like orders of magnitude improvement here, at least as he describes it. And similar numbers he said you could find for rice and other staple crops. But this, of course, was made possible by externalizing the energy to fossil fuel. And so he gives the number that for 1 kilo of sourdough bread, as for a loaf of 1 kilo of sourdough bread, it requires the energy input of at least 250 milliliter of diesel fuel. So you could say a quarter of what you eat is diesel fuel. And incidentally, for tomatoes in Spain, he gives the numbers for 1 kilo of tomatoes. You need something in the range of 150 to 500 milliliters. So nearly half the amount of tomato you eat is again equivalent of diesel, depending on if you heat the greenhouse or not. That's the number that he provides. And interestingly, pretty much the same amount is for chicken. So chicken, he says, like in the US, has about, I think, if I remember it correctly, 250 milliliter of diesel for a kilo of chicken. So do you agree roughly with this assessment? And I mean, I think the bottom line is that we're eating fossil fuel in one way or another.
Yeah, so in that regard, yes, I agree. I mean, the energetics, I'm going to trust him on the numbers and assume that is correct. I do think it's a oversimplification and it misses some nuance. Particularly thinking about the wheat, for example, and the time invested, right? So time and energy, yes, they're linked, human energy, human time, but it's not only that. One of the great inventions, which is a lot of people think very poorly of, but it really revolutionized civilization in many ways, was herbicides. Prior to the invention of herbicides, as you mentioned, huge amount of time and labor was spent on growing crops, and a lot of that time and labor was just weeding. I read a statistic, and I don't want to quote it because I'm not sure, but I think it was something like 50% of all human labor ever was just spent weeding, at least since the agricultural Neolithic revolution of agriculture. And herbicide just changed that, and it allowed society, therefore, to change, because suddenly there was a huge pool of labor freed up. Of course, mechanization had a role to play, but without weeding was something that was very hard to mechanize. I mean, you can plow, you can disturb the earth, you can do it to some extent, but herbicides really changed that. So yes, there was improvements due to mechanization, and that allowed the time and energy requirements to shift away from humans, but to basically machines. But some of that was also due to innovations which made the whole process more efficient.
By the way, this was my oversimplification. In his book, he of course also refers to the chemicals, to the agrochemicals that are used.
Oh, right.
So this was just my oversimplification. I just wanted to break down the enormous improvements in efficiency. This was actually my core point. And the energy requirements he listens are sort of a full end-to-end accounting. So also includes agrochemicals. So not only like what you need for the production of agrochemicals. Yeah. So this was my simplification.
From an energy perspective, yes, but also just thinking about that time investment of humans, that does free up a lot of time. And then just in general on the framing, so like looking at this in the context of fossil fuels, right? Basically looking at agriculture in the context of CO2 emissions. And food production, agriculture is responsible for about a quarter of global CO2 emissions, and food systems as a whole are responsible for a little over a third of global CO2 emissions. So significant contributors. However, I think this is a very limited perspective to look at food systems and their role in environmental sustainability, because their impact is much greater than just looking at through the lens of carbon would show. They're the main. I find the planetary boundaries framework to be a much better framework to look at these things through. So maybe, I mean, there's a link. You can provide a link to that to the listeners. This is work from the Stockholm Resilience Institute, and they identified 9 planetary systems which should be kept within a so-called safe operating space for life as we know it to continue, civilization to continue. They range from things like the ozone layer to CO2 emissions, for example, and many others. And of those 9, for 5 of them, we are outside this safe operating space. One of those 5 is CO2 emissions, global climate change, which is the one that receives the most attention. But there are still 4 where we're in a really bad place. And of those 5 where we're outside this safe operating space, the main driver of 3 of them is food production. So that's land use change, biodiversity loss, and our biogeochemical flows of nitrogen and phosphorus, which are causing global eutrophication and all sorts of problems in our water systems. And as I've already mentioned, food production is a big contributor also to CO2. So why I'm making this point is that if you only look through the lens of CO2 and energy, you would say, well, you know, modern developments in agriculture have been bad because they require us to use more energy. So we should go back to the older ways where we use less energy, which to some extent is what some of these people that want to go for agroecological farming, organic farming, that's what they're leaning towards. But that means that you're not paying attention to the other impacts of food production, which are sometimes even worse, such as the massive loss of biodiversity, the so-called 6th mass extinction event. And I think those are really serious issues that need to be addressed. And I also believe, or at least I'm optimistic, that we will develop technology such that our energy will not need to come from fossil fuels. And that's already happening. And I think it will continue to happen. So in order to be ready and to take full advantage of those developments in energy production, we need to rethink how we do food production, especially to minimize its physical footprint. Mm-hmm. The biggest problem with food production is the fact that it's just so extensive. It is so massive. It takes up such a huge area of the planet. 50% of the habitable land mass is used in one way or another to feed us. Effectively, we've eaten half the habitable biosphere. or are continuing to eat. And that is not sustainable.
Yeah.
And as our population increases, if we don't come up with a different way of doing this, it's only going to increase. And there's not really enough land left for that. And if by doing so, we also push life out of these spaces. And people will say, well, organic farming, agroecological farming, there's more diversity in the farm. It's better in that respects. And yes, if you just compare it to conventional field, that's true. But it's not better than a natural ecosystem. It's not better than the wild. And what we should be focusing on is allowing more space for the wild.
I think it's very fascinating what you said. I also have the impression that today, even though without a doubt, carbon dioxide emissions and climate change is certainly an important topic, but the total focus on this as if this is the only issue that we have to look at, I think is a major mistake that we're making.
We call that carbon tunnel vision.
Exactly, carbon tunnel vision, exactly, yeah. So the planetary boundaries is very interesting. I'm going to link to that. This was started in a Nature paper, and then there is the website of the Stockholm Resilience Institute. I'm going to link to both so the audience can get a better idea. Then, by the way, because he's talked about biodiversity loss, I had 1 or 2 years ago, I had a biologist here from Vienna on the show, and we talked especially about biodiversity loss. So also the link will be in the show notes. So if you're interested in the biodiversity topic, so you can get also more information there.
And we've had some good news on that just in the last few days with COP15 and the 30 by 30. I haven't actually had time to really read into it. I've been too busy working with my plants in the greenhouse. But it seems that we now have new targets to try and prevent that biodiversity loss and provide more space for nature, which is good to see. How we will actually implement them is another thing.
Yeah. Actually, and so I think what I find very important, what you're saying, is exactly the problem of land use. And two things come to my mind. One is maybe one I just want to refer to other episodes is I think we underestimate the effects of land use also in energy production, because the idea that it's a clever idea to make whole landscapes full with wind turbines and solar cells escapes me how this can be useful, because people do not understand what energy density means. And when you go with extremely low energy density production, then you use a lot of land plus an enormous, actually you use the land double, because you use the land for the windmills and you use the land for the resource extraction, because you need an enormous amount of resources for that. So you have to mine them in another place. So that is the energy topic. Anyway, but considering the agriculture to come back, so also, as you said, I think 50% you said roughly of our ice-free land.
These numbers you can find and very nicely visualized on Our World in Data.
Or maybe I should.
So they've done some nice write-ups on that.
I will maybe also link a graph there. And so this means, in effect, my understanding from what you said is this: it is also very important to think of how can we highly efficiently produce food in terms of land use. And my understanding of organic farming is that it has at least 20 to 50% more land use need to produce the same amount of food. And now, even if you say, okay, it might be a little bit more biodiverse on the farm, but still 20 to 50% more space to feed humanity, I think is just prohibitive, particularly. And that's the next fallacy, in my opinion, is that we think about, okay, what are we doing in Austria or Germany? But the important question is, what are we doing globally? Because what do we do in Germany and Austria is quite irrelevant in a global perspective.
Well, it can be relevant in the sense that the EU now, with its farm to fork strategy, wants to convert something like a quarter of farmland to organic. And then to make up for that food shortage that will come, I mean, where's that going to happen? It might not happen in the EU because we can afford to protect our ecosystems and whatnot, but it will be offshored. And there will be environmental degradation elsewhere. What we do here does have an impact, even
True.
if, but often it has a very negative impact outside of our borders.
By the way, this farming incidentally is not the only case where we do this. We also like to use iPhones, and we like to use computers, and we like to use modern technology. Yeah. What we do not like so much in the European Union is mining. So we do not do mining within the European Union a lot, but we import the goods or the materials or the precursors of the products from all over the world where the mining is done. And similar, like we see in Germany now, we do not want others to use fossil fuel, but at the moment Germany uses for its energy production 80% coal and imports gas from all over the world. So this is also a little bit hypocritical, in my opinion, to say, yeah, we do good here, but actually we externalize our problems to the rest of the world.
Yeah, no, that's true. And I think especially talking about the German energy mixture, and it's been very topical for the last year, especially since the invasion of Ukraine, is the role of nuclear. I feel like the conversation is shifting there a little bit, but in a positive way, and that more and more people are waking up to the fact that nuclear technology does have a role to play in a low carbon energy system, and especially in terms of land use efficiency and resource use efficiency. I think it really has a role to play. And it is also, I mean, that's another case. People are afraid of the unnatural in food. They're also somehow afraid of what is perceived as unnatural or somehow beyond what would naturally happen in energy production, which is nuclear. And because it's scary because you don't understand it. And of course, there have been disasters, but far more people die from coal.
Yes.
But somehow, I don't really fully understand the psychology of it, but because it seems somehow less strange and more familiar, we are less disturbed by this massive death toll than we are by a very relatively small death toll with nuclear.
Yeah.
So when we weigh risks, we're just not weighing them correctly because our perception on things is completely skewed.
Yeah, it's a very interesting point too. Maybe I should do an episode once with a psychologist about these things. But maybe let's turn back to farming. Now, maybe as a last topic that fits into this organic thing is, I think we saw, at least from my perspective, what can happen if you do things from the political side not too clever. Like 1 or 2 years ago, Sri Lanka was like a poster child for some activists as how you should proceed with going away from traditional farming to organic farming and so on. And then we saw a big disaster actually in Sri Lanka with disruptions. And if I have the numbers right, after the president made the decision to ban synthetic fertilizers, the crop, I think, was reduced by 20% just after the first months, and led to a significant disaster in political and economic and food shortages. And suddenly they had to import rice. And then we really have to ask ourselves, this certainly cannot be the future, can it?
No, I mean, I think so. The case in Sri Lanka is a complex, multifaceted one. The motivation of the politicians to transition from what would be called conventional agriculture to organic agriculture, I don't think was really motivated through a love of agriculture, but they thought they could get away with it and not have to spend so much money importing all these fertilizers, because of course they were led to believe that it would work, and well, that wasn't true. And I think it also clearly shows how food security is also a national security question. And this should be obvious to anybody who looks at history and past civilizations, looking at whether they've survived or not. A lot of the time it's dependent on whether they've managed to keep their food supply stable and reliable. Political systems require a stable food supply in order to stay in power and in order to provide security and stuff for their populations. So yeah, I mean, Sri Lanka is now receiving a lot of external aid, well, trying to get it back on its feet. Of course, they've rolled back those policies which were poorly conceived from the beginning. And in a way, it's a little example of what could go wrong should you take a dogmatic approach with food production. And especially, I say the word dogmatic because non-scientific. That's one of the things that upsets me most about organic is you have a lot of people, well-meaning people, who are not experts on food systems, and why should they be? We cannot all be experts in all these things. And they go to the supermarket and they're willing to spend more money to buy organic food, regardless of whether they believe it's better for themselves, but also because they believe it's somehow better for the environment. And that goodwill is being used up inappropriately. They think they're doing something good, and in the end, for most crops, it's not net beneficial. It's actually worse for the environment when you look across all metrics than conventional food production. And they're even spending extra, thinking they're doing something good, when in many respects they're probably causing more harm. And that for me is very frustrating. And I feel that there is, a lot of people don't realize, but a very strong organic lobby as well. I mean, Whole Foods is now owned by Amazon.
Yeah.
It's not a case of, big business is conventional and small artisanal business is organic. I mean, that dichotomy may have been true 30 years ago, but it's certainly not true anymore. And there's invested interests in continuing to promote this sort of story, this marketing claims, which is not only wrong in the sense that it's incorrect, but it's wrong in the sense that it's misleading people.
Yeah. I also find it fascinating. By the way, I brought this in another episode too. I'm not an agricultural expert, obviously, but I'm also very much disturbed about the collusion between problematic agricultural ideas and also a lot of pure esoteric. Because when you read up what some of the largest German organic producers do, this is like fairy tales, like putting horns of cows in particular pieces of the feed.
Biodynamics.
Yeah, it's when you read, and I'm not making that up. In the other episode, I'm going to link to. I also have the references to the websites of these producers where they make all of these explanations on the websites. So this is fairy tale land, and as you say, I think people.
But it's absurd.
Sorry?
It's absurd. Well, I mean, most organic is not as absurd as that. To defend them slightly. But what is absurd is often what is allowed in organic is allowed not necessarily because it's safer, but just because we've done it like that for a long time. For example, we use mixtures of copper sulfate and stuff
that's
to
a very
control
good story.
potato blight, which is more toxic in many respects than conventional fungicides, and it doesn't degrade. It's elements, it's metals that then can accumulate in the soil and also ultimately bioaccumulate. It's not safer. It's not better. I myself, before I was doing fieldwork in Kenya many years ago, I was in Mount Kenya and the Aberdare forest, which are wonderful ecosystems. These African rosewood forests, Aginia trees, beautiful, beautiful ecosystems. African montane forests. And then we went to the Cherangani Hills in the west of Kenya, and it would normally have similar ecosystem. But it had been cut down and it was heavily degraded, and it was very sad to see. And one of the reasons they were cutting it down was to plant feverfew to extract pyrethrin for organic insecticides, which would then be used in Europe. And I thought, this is just bizarre. This is not better for the environment. They're cutting down these wonderful forests to produce so-called organic insecticides, which are also quite toxic. I mean, it's a toxin. Just because it comes from inside a plant doesn't mean it's safe. And conventional ones manufactured in a factory can, in many cases, be safer. We have more control over them as well. And ultimately, that's why I mentioned dogma earlier, is that it's dogmatic organic. It's not evidence-based. If it was evidence-based, I would be all behind it. And I would love that there would be a label indicating the sustainability and the healthfulness of food, which was evidence-based, and where the rules or the regulations would be constantly updated as new knowledge came. But organic and stuff, it's not constantly updated. It's stuck in the past. And that's a real problem, especially when you have a changing landscape such as we have today, where there's more people, there's more requirements. The world is not the same as it was 100 years ago. And we have to keep adapting to that. And dogma is not adaptive.
Maybe just to conclude on that part, and tell me if I get it wrong. The one thing is that I'm repeating over and over also in my podcast is usually problems are much more complex than they look on the outside. And every time when you suggest a simple solution, it's usually nonsense, or you just overlooked something. Sorry, yeah? Silver
bullets are only good for killing magical creatures, right?
Exactly. And as our problems are not magical creatures, exactly, we usually are overlooking a lot of stuff when we think we can solve this and that problem by that and that simple measure. I think that's the same thing evidently here in food production. The second thing that just became clear to me now in this conversation is actually the strong overlap in many regards of food security and energy security, or the two systems in some way, not only that like food is depending on energy, but also in the sense of like land use and food security, energy security are just very fundamental things for a modern society. You cannot live without.
Well, food is energy. Ultimately.
Exactly. Yeah. Exactly. In a particular type. True. Exactly. Yeah.
It's energy in a form that we can use. And a lot of what we need to do as a global society is to manage energy flows better. Energy and matter, right? We need to understand how to manage those resources better. And we're now a globe, whether we like it or not, we're a global civilization. And our impact is global.
Yeah.
And we need to start thinking global. And that is something which is beyond my area of expertise because it really comes down to policy. It comes down to international relations and how well we manage those. What I try to do in my work is to develop at least some technology so that will be available should we manage to organize ourselves. At least it hopefully won't be the limiting factor, but this is going to require a lot of good politicians, and I worry as to whether we really have those, or at least enough of them.
Yeah, that's a very, very astute point. Before we come, actually, this thought of food and energy and food as energy is really very fascinating, and I didn't think that through in its depths. I think also because we had all of these things like biofuels, creating like fuels for cars from crops, or we have the whole thing like now we are producing electricity with biomass, which also sounds like a ridiculously bad idea.
Yes, I would agree.
In various regards, or we have like one of the maddest project I've heard recently is like a cooperation between Canada and Germany, where they have the idea to produce renewable energy in Canada, make hydrogen out of it, and out of the hydrogen ammoniac, which has unbelievable losses in energy, and then transport the ammoniac to Germany to burn it in power plants. Like this has so many. This is one of the recent plans of the Germans to produce quote unquote green energy. Now, not only do you have so many losses on the chain, you're actually burning food, because ammoniac is one of the core substances for fertilizer. So you're actually burning fertilizer in a coal power plant.
I guess this is where economics really fails us, because economics should be about trying to improve efficiencies and replicate or at least reflect some sort of reality. But that might make economic sense, but it doesn't make sense in any other world.
I think
that's where
I'm very
that's just silly.
I'm very critical about economics, but in that case, it's not the fault of economics, because economists write that this is nonsense. This is just the political idea. Now suddenly hydrogen is green, and whatever we do with hydrogen is now green.
Well, it depends where you get it from, right?
Not only that,
hydrogen,
most notably,
it burns clean. It's very dangerous.
Exactly.
Very explosive.
You cannot, you cannot store it properly. You cannot. Yeah. It's also climate gas, which is also never mentioned. And if you have a chain where a lot of hydrogen escapes in the chain, and so on and so forth. Anyway, let's stay with agriculture to come now to the future of farming, and maybe also one last aspect to the impacts. What is your take on meat? Because meat is always very disputed. On the one hand, I mentioned before that some types of meat, like chicken, seem to have a comparatively low environmental impacts. Other meats seem to have a higher impact. On the other hand, Václav Smil also writes that certain types of vegetation can be digested by certain types of feedstock that you couldn't otherwise. So also here it seems to be a little bit more complex than usually discussed, right?
So meat is, as you mentioned, a complex topic, and also in a way simple. So it's complex in the sense that you have ethical questions about the use of animals, that you can bring in these concepts of, well, there is this unused biomass which cows can use and other animals can use and they can recycle, and all of that is true. What is simple is that the amount of meat we eat and the energetics required to get that to our plate, it's clear, beyond any shadow of a doubt, that this is a very inefficient way of getting food on the plate. My perspective on meat is the perspective that meat should be as it was. And what I mean by that is meat should be a luxury. It should be a special occasion. Many of our festivals, carnival, you name it, literally in the name, it was about the opportunity to eat meat, because meat was a luxury item. It was something special. And we don't need a lot of it in our diet. We can get most of the nutrients we need from other sources. That said, there are new technologies coming online which may allow us to produce meat without the ethical questions, and in a way which is far more sustainable, but they still require a lot of research and development. And I'm referring to, of course, is these lab-grown meats. Some of which have already been commercialized. I think in Singapore, they now have lab-grown chicken nuggets.
They do? This is commercial already?
Yeah, on a very small scale, I believe, and very expensive. But that's with all new technologies. That's how they start. That's not necessarily indicative that it's a failure. It has to start somehow. There's still a lot of research to be done, but this is not, of course, the only space that will address, hopefully, the issue of meat. But there's also meat substitutes derived from plant or precision fermentation, which can now produce things which are almost indistinguishable from meat. I mean, if you go to Burger King today, you can buy your Impossible Burger, your meat-free Whopper, and it's pretty hard to tell the difference. That, of course, is not so easy to replicate with something like a steak, where there's all sorts of texture aspects and which are much more difficult to replicate. But we're getting there. And I certainly think one thing about meat for me is clear, is that it should not be receiving the kind of subsidies it's receiving. Mm-hmm. And that's one of the reasons we're in such a terrible place with regards to meat and the environmental impacts of meat production, is that it is much cheaper than it would ever be without those subsidies. And those subsidies are, of course, politically motivated for various reasons. Those should go away. And then I think meat would be a lot more expensive, and therefore we would eat a lot less. There are, of course, other questions which then pop up, which is that fair? What about those that cannot afford meat? Should that be only the rich can afford meat? And I think, no, definitely not. And I think there are potentially ways to solve that, but I'm not going to go into that because it's very outside my area of expertise. I'm a plant geneticist, and I shouldn't be speculating too much on policies regulating meat production and the price of meat globally.
But anyway, we are already actually in the middle of the last question. I wanted to ask you, looking towards the future, maybe present and future, like what is the future of farming or future of food production? So what technologies do we have now that are maybe misunderstood partly or that are just in development? By the way, I found it very interesting. Carnival, that this word is connected to meat, and it never occurred to me. It's very
no, that's it.
It's
the meat festival.
No, it's good. It's funny. I never made this connection. Anyway, so if I ask you about the future of farmings, which general trends would you observe? Yeah, what you already mentioned once. This would be like one that would be like lab meat or synthetically produced meat, maybe, but there are certainly a number of others. Could you maybe give us a bit of an overview? What, practices,
Sure.
Technologies, what is in research going on there?
So, from my perspective, the one thing that has to happen if we are going to be a sustainable and successful civilization long term, right? We need to figure out how to feed ourselves. And this can all be boiled down actually to a single word, which is decoupling. We need to somehow decouple food production from ecosystem destruction. And today, right now, our food production has massive externalities. It's destroying our planet. We are eating our planet. This is the simple way you can describe it. And there are a whole range of technologies which are in development or already existing, which can help us to decouple food production from ecosystem destruction. Now, a lot of them require a lot of energy. So as we've discussed already, this also requires innovation on the energy sector. One of those is indoor farming. This is the space where I actually work. And this allows us to produce food in a more resource use efficient manner in terms of land use, in terms of nutrient use, without the need for chemical pesticides and the likes. But of course, it requires more energy.
Can you briefly explain, because I think this is a good example, what indoor farming means, because maybe many people have not a clear idea what it actually means in practice.
Yeah, so indoor farming is kind of what it sounds like. You grow plants indoors. What matters most about it is you grow them under a controlled environment. And this provides you with a lot of opportunities. One is that you no longer, if you do it right, have disease and pests. So that is one of the great costs in outdoor food production, is that you're always fighting against these, either through the use of chemical pesticides or through very active breeding programs. And you're basically on a treadmill, and the faster you run, the faster the treadmill goes almost. You're just trying to stay in the same spot. It's very expensive. In many senses of the word expensive. And so there's that one thing that goes away. And then because you grow it in a closed system, you can recycle all those nutrients and that water. So your water use efficiency goes up by orders of magnitude. You know, when the plants grow, they transpire, they emit water into the atmosphere in the indoor farm that is then condensed and put back into the system. So your water use efficiency of your crop is now part of the growth system. So you don't need to create drought resistant crops, which often comes with a yield penalty. You can grow crops that do not require that. The same applies for the nutrients. the only nutrients and water, if you run your system correctly, that leave are what's in the end product, what's in the food. So this means less problems with regards to biogeochemical flows. One of those planetary boundaries we mentioned, the phosphorus and nitrogen being spread all over the planet, is now enclosed and used much more efficiently. That also has impacts, of course, on the nitrogen in terms of energy use efficiency, because nitrogen is very, very heavy on energy requirements. The water use efficiency is really important for being able to produce food in a resilient manner. So this isn't just about producing food more sustainably, but also producing food in a way which is less susceptible to the climate shocks that we are going to experience going forward in the future, which is very important also for societal and political stability.
Maybe not only climate shocks, also let's think of supply chains, because when we have a food supply that is importing, I don't know, potatoes from the other side of the globe, then this is clearly also a resilience issue, right?
And much of our produce, if you go to the supermarket, you find snap peas. I just looked the other day, the ones here in the local supermarket are from Ethiopia. The blueberries are from Peru. There's a lot of questions associated with, is that really a sensible way to produce your food? And with indoor farming, the other advantage, of course, is you can produce it anywhere. It doesn't matter where on the planet. You can produce it in the deserts, if that makes sense, for large-scale staple crop production, or you can produce it right next to the consumer for fresh produce in the city, just outside the city, whatever. That then, of course, means that the quality of the food, the freshness, and the supply chain issues are completely different and, in many respects, considerably reduced. So there's a lot of potentials with indoor farming to really do that, what I spoke of, which is this decoupling, because now you can produce an enormous amount of food on a much smaller footprint, physical footprint, and also much more resource use efficient.
But one last question about indoor farming. As far as I understand, you're also not growing on soil, right? So you're not using soil.
Yes. Well, so in the space, in the industry, there are those that do use soil. Mm-hmm. You can use soil. There's no reason why there's no rule that you cannot use soil, I should say, but there are reasons why you wouldn't want to do it. Because once you use soil, you introduce pathogens, you lose that control, which is really important for that cleanliness, that is really important to prevent disease, which ultimately has a big impact on the efficiency of your system as a whole. So generally it's done using these hydroponic solutions, which is also why you can recycle the nutrients and the water very easily, because you have that kind of control. Once you put soil, it gets stuck in there. You get pathogens. It's just a more complex substrate to work with. But answering your question also beyond indoor farming, other technologies. So obviously biotechnology has a big role to play in the future of food production in many aspects. So one of them is just improving our crops, which is the classic thing, the debate, GMOs, genome editing, these kind of things. Can we use them to produce more efficient crops, healthier crops? And the answer to that is yes, we can, if we are allowed to. But then there's the other topics. So we've already talked about lab-grown meat. Perhaps if we made some genetic modifications on those cells, it will be easier to grow a steak in a petri dish than just using unmodified beef cells, which obviously have not evolved to grow on a petri dish. They've evolved to grow inside. I can see how a lot of improvements can happen there. And then one of the most exciting areas is precision fermentation.
I'm sorry, before we go to precision fermentation, I would really like to get a good picture about that, but can we briefly stay with GMOs, because I would like to get a little bit more of your ideas on GMOs, particularly because many people fear the risks of GMOs, and you have now on every package, you have no gene and stuff like that. So, okay, there's clearly no gene in the food that you eat or something like that. I don't know. So,
yeah, that's very silly.
I mean, there are, I think, some concerns, of course, when you modify the genome of organisms that something could go wrong. I mean, this is not necessarily
well, I mean, it comes back to something we spoke about earlier, which is risk and relative risks and human perception of risks. I mean, there is nothing without risk, including doing nothing. That has risk, right? Everything has risk. Every action or inaction comes with risk. It's all about balancing those risks and weighing them up and choosing that which is less risky. And compared to doing nothing and continuing to produce our food as we have for many thousands of years, doing something has less risk. I would say, because we know doing nothing is leading us down the path of complete unsustainability and ecosystem destruction. So we have to do something. And when it comes to GMOs, what is classically, so GMOs is a rather complex topic and space. So interestingly, according to legislation, we already eat GMOs in Europe, but there are a specific class of GMOs which are not regulated as GMOs. So we have conventional breeding, which relies on mutations which occur naturally at a constant rate, more or less, and then we see them, we select for them, we cross different individuals, we even cross different species, which is a rather crazy thing to do that wouldn't normally happen in nature, but it's considered natural breeding, if you will. And we can go forward with that. And in addition to that, we also have mutagenesis, which is considered a GMO according to legislation, but not regulated as such. This is in Europe, by the way, what I'm speaking about. So this mutagenesis can happen either through the use of chemical means, so you have chemical mutagens like EMS, or via nuclear bombardment, so you can irradiate plants or you can expose them to different things which will basically damage the DNA. And then you grow the offspring of this, so you basically massively increase the mutation rate in order to generate new and interesting variation. And this was a very popular technique in breeding 50 years ago. And much of the crops that we eat today are derived from these mutagenesis experiments. Pasta, almost all pasta came out of mutagenesis experiments. If you've eaten ruby grapefruit, that came out of a mutagenesis experiment. These are technically GMOs, and they're GMOs made in a very crude way. You know, just go break things, see if something useful pops out. If it does, select on it, and you have a new food. So if anything, that would be a risky approach. Now we know that it's not, I mean, obviously you could produce a plant accidentally that produces a toxin, but you usually notice that pretty quickly and you don't commercialize it. So the level of control and the level of precision is very low. It's a messy approach, but it does yield results. Now we have advanced, and now we have a case where we can do targeted mutagenesis effectively, which is what we often call and regulate as GMOs. That can either be copy and paste. So transgenesis, you take a gene of interest, you copy it and put it in another organism. You then try to express it there and it does its function there. And then you have genome editing, which is this new CRISPR-Cas. This is what the Nobel Prize was won for and recently. And this allows you to make very targeted mutational changes in the genome.
I'm sorry, Pádraic, we had a short breakup. You said, let me just conclude that the thing that I heard was you talked about the mutagenic things like with radiation and all of that stuff. So to speak, we shoot with maybe with a gun into the DNA and hope for the outcome.
Yes.
And then you said, okay, but today we have, and this seems to be no problem for many people, but today we have much more focused ways to make the changes. Could you see continue from there?
Yeah, sure. So we now have what are regulated as GMOs. Transgenesis, which is this copy and paste, effectively, where we would see a gene in one organism that does something, copy it and paste it into another. This is the classic GMO, the one that all the debate was over. And then more recently, we have what's known as genome editing. This CRISPR-Cas, this is what the Nobel Prize was won for a few years ago. And this allows us to make very precise edits into the genome, targeted and let's say without adding any DNA, which seems to be a big deal for a lot of people. You can just edit what's already there. So it's targeted mutagenesis effectively. And there are now new variants of this where not only can you break genes, but you can base edit. So you can change some of the base pairs to change function of the gene. And the technology is rapidly developing. From the outside, without bringing any emotional baggage to it, in many respects, it's safer because we have more control. We know what we're doing. Now, with all these things, of course, that control, and I think that scares people, is actually the fact, to some extent, that we have more control. Because that means that people can now do things which in the past would have been very difficult. So in other words, they could make something dangerous if they wanted to, right? Now that is a question of how the technology is implemented and how it is regulated. By banning it, you're not getting rid of that risk. If anything, you're increasing it because you're putting this technology into the black market space. That's where it's easy enough now that somebody with a relatively unsophisticated laboratory can already do many of these things. By pushing it into the dark, if you will, that is not the way to get rid of this risk. If anything, it'll only enhance that risk. So that I feel is not a good argument. And then the whole idea that it's more dangerous than conventional breeding, there is no evidence to show that. If anything, there's evidence and reason to think that it's safer because, of course, you have more control. And that's not to say that conventional breeding or mutagenesis is inherently risky. It's not really. This whole thing has been totally blown out of proportion by debates. And I think, again, it comes back to this naturalistic fallacy and all these other things which are holding us back.
Okay, thank you. This was a very good, interesting wrap up about the GMO thing. But stuff that is also pretty new for me is what you mentioned before, is precision fermentation. This is something that honestly I have to say I didn't come across until you told me about it. Can you maybe give us an idea what this precision fermentation holds in store for us?
And so precision fermentation is kind of what it sounds like. You would take organisms that we already use to some extent for fermentation, whether those are single-celled yeasts or some other fungi or bacteria. And many of these organisms are very, very easy to manipulate genetically. And we can add genes or remove genes, and we can add whole biosynthetic pathways. We're very good at this already, and we're only getting better. Basically, we can use those by providing genetic instructions to make a vast array of biomolecules, whether those are proteins for food or bioactive molecules for medicine, you name it, we can make it with these things. And the limit in many respects is our imagination, our creativity. And the cool thing, of course, is that the instructions can just be kept on a computer, and then you can send them to the other side of the world. And then that person can then take those instructions and synthesize those genetic constructs and implement it. So it's, I also think, going to allow for a democratization of biotech and the implementation of that biotech. And it will also allow for, should the IP be regulated correctly, a distribution of the innovation globally, because it's not that hard to do. And it's tightly linked, of course, to synthetic biology, because it's all about creating new things. So a lot of it will be copying from nature, because nature has already innovated significantly in the number of and range of molecules we would want. But also we can think of making totally new things. This is going to be really important for food, for medicine, and probably for industry as a whole. It's going to allow us to shift to this so-called bio-based economy, where we will maybe not need to do such extreme resource extraction, which again is really important for this whole decoupling, both for food, but also for our society as a whole. For our society to progress, we need to somehow not require environmental destruction for economic and social advancement.
Can you just give us maybe one or two or three examples of what could be produced by this precision fermentation that people would recognize as food, or I don't know, in their daily life?
I was in contact once with some of these biohacking communities. I don't know if you've heard of them. So these people that want to use these technologies and want to ensure that they're not controlled necessarily by a single entity or large industrial corporations. So they do it in their basement and things like that. Often very idealistic individuals. And some of them, one particular community, were vegans, and they really wanted to use this technology so that they could continue to be vegan, but basically effectively eat the proteins that are found in meat. And one of those, of course, is casein, well, not in meat, but in cheese. So they wanted to create a cheese where they produced the relevant proteins via biofermentation. And one of the funny stories for me was they decided the best way to do this, which would be completely hypoallergenic, was instead of using the genes for cow casein, rather use the gene for human casein. So it's just a single protein you would make, and now it's hypoallergenic. I mean, it's literally evolved and co-evolved with us. People will not have problems. But because it's a human gene, they weren't allowed to do that because it's somehow considered wrong. But this is something where we need to advance, I think, our understanding of things, our feelings about things. Feelings are really important in this space. And our ethics and how we regulate this, because I do not see a problem with this. There's no real risk. If anything, it's safer in many respects. So that would be one kind of fun example. But
sorry, we have some quiet noise with the microphone. Did you?
Oh, sorry. I think it was me. I touched the cable. Is it better now?
Yeah, it's better now. Okay. So you mentioned you mentioned insulin, so pharmaceuticals essentially, right?
For example, yes, and medicines that we probably never even considered. Any of these bioactive molecules you can produce a large range of them inside using precision fermentation. There may be some molecules which we will have great difficulty with because the chemistry is such that they can only be currently produced in trichomes of plants because they require chemistry which is not conducive to single cells to survive. Might be those limitations. But for the most part, the limitations are, I think, and I say this, and I don't say this lightly, literally our imagination. So you ask for examples. Maybe you can think of something, think of anything really, and we can probably produce that.
I'm thinking of biofuels. Could we produce diesel in an efficient and ecological way?
Well, we could certainly produce it, and we could produce the fats. Whether it will be efficient and ecological, I don't know. I think in the end, for most of that, we would want to be going to battery-operated transport because it's just more efficient than having these. Maybe in the case of aircraft, we will continue to use that. And then you could consider, using algae to directly take sunlight and convert it into biofuels. That would be not, in my mind, the first use that I would think of for precision fermentation.
Okay.
I think the energy questions are better solved in other ways. Direct energy capture from the sun, nuclear energy, things like that. Mm-hmm. There probably will still be a role for fuels, but and certainly precision fermentation can speak to that and can provide solutions for more efficient conversion of those raw energy forms into a reduced carbon form, which is effectively what a biofuel is. And yeah, it could do that. But I think it's much more exciting what it can do for our food supply and for providing an incredibly diverse range of foods, cheeses, probably meats, any processed foods. I think it can really have a role to play there.
So theoretically, we could produce a vegan steak. Is this correct?
Yeah, I think so. And so that will probably can happen via precision fermentation and also can happen via modification of plant-derived proteins, so peas or soybeans, and that's already kind of happening. Maybe not the steak, but certainly the burger. And then it can also happen via direct growth of cells of cattle. And I think we're exploring all of these options already. Which one will come to be the dominant form, I don't know. There are pros and cons to each of them. And if the precision fermentation can truly replicate something like a steak, then I think it will outcompete the direct, like growing the cells of a cow, for example.
Fascinating. Maybe just as a last question. There is a lot going on here in biotechnology that could actually give us hope in modifying our food production, but going beyond the food production over the next decades or maybe within this century. My last question maybe would be, what brought you into this field and why is it fascinating to you? And maybe associated with this question, if someone in the audience maybe is a student or a pupil in school or so, and they have the feeling that sounds fascinating, if I would like to get into that field and work on these new ways of researching or producing food, what would they have to do to get into such a position?
Sure. So to answer the first part, how did I end up here? I suppose the root of it is I've always loved plants, and I've always been fascinated by plants for as long as I can remember as a child. And my father taught me the word for somebody who studies plants as a botanist. And when I was a kid, and they would go around the class asking the kids what they want to be when they grow up, and they'd say, fireman or nurse or something, I would say botanist, which I think always surprised the teachers. I don't know why, but I've always loved plants. And I followed that passion, and I did botany as an undergraduate, and then I did a Ph.D. in plant genetics. I also liked genetics. I liked the interface between the two. And then I continued along the academic track for some time, studying how plants, different aspects of plants, how they adapt to extreme environments. That's how I ended up in Africa doing field work. I really loved it. And then I was transitioning in the academic career path. You do your Ph.D., you do a postdoc, and then there's this difficult transition to a assistant or associate professorship, basically becoming a group leader. And I was on that transition phase, and I was very dedicated to it. And I was actually writing for a German grant in Emmy Noether. And then the pandemic hit, and there was no longer childcare available. And I had planned to write it I had a few months off between contracts, and I had planned to write it then. And I had two young children, which I basically couldn't work on a grant when they were around the house. So I took a step back from the grant, focused on being a father, and I had a lot of time to think. And then I started thinking, although I really liked what I was doing, and I found it very stimulating and very important, and it's fundamental science, and I'm still a big proponent and fan of fundamental science, I felt like what was happening with the pandemic was a little sample of what was coming with regards to the global ecological crisis we're facing, the global environmental crisis we're facing. Only that those, climate change and such, are even worse than a pandemic because they're more complex. There's no vaccination for them and they're harder to solve. And I thought, my God, if we're doing this poorly as a global society against a pandemic, which relatively speaking is simple, not to say that it is simple, but of course, relatively it is, I'm really worried for the future of my children. And I'm looking at them there, they're just toddlers, and I'm thinking, am I using my time wisely considering their future? So that for me was the first step towards thinking, how do I use my knowledge in plants and in genetics to contribute to a safer, healthier, and more sustainable future? And I've always been interested, as I said, in plants, but also specifically in crops, in food plants I've always liked. So this was a sort of natural step to start thinking about how I could do that. And it took a while. It took about a year of thinking and exploring different options. And I eventually settled on developing new crops for indoor farming because I think that has a real role to play in the future. So that, in a nutshell, is how I ended up going down that path. It wasn't completely intentional. It was really a response to a perceived need, at least from my side, that I should be doing something and I should be proactive. And we all have different things we can do. And for me, I felt that I could help address food supply issues and the sustainability of that food supply. Then regards to how could people get into this space, as I've just outlined, my approach to this was not a linear path. It wasn't really targeted. I think many people, I would say food is one thing, of course, where we really need to address, right? I mean, we have to eat. We have to produce our food more sustainably. And there are many aspects to that, policy, technology, you name it. I think you should look for what aspects of this system are interesting for you, whether you're interested in the production side, the supply chain, the policy, and then think and explore what needs to be done in that space. And then if you're, depending on where you are, what would you need to study to help that, or how could you reorient your career towards that? And to be honest, I think this applies to more than just food. I think as a community, we should be thinking more about how we can use our time, our skill, our knowledge, and our career to create a more sustainable future. Because frankly, we're in a crisis. We're in a global crisis, and it's not going away. And we all need to try to do something towards that. Now, not all of us can be directly involved. And of course, there are many roles in society which are still needed and people need to continue to do them. But if you think you can contribute, and if you think that your skill sets have value, then I would say go out there and start doing it. Beyond that mindset, I can't really give, it will be so different for every individual what you will need to do and what you will need to study, depending on where you're coming from. But I think you should ask yourself those questions. And if you think you have a role to play or could have a role to play, then be proactive about it and start moving towards that. And if you're lucky like me, you'll be able to find a space in a job where you can get paid to do something which seems like, or hopefully will have a positive contribution in the future.
I think this was very good advice. And for me, this was a very, very interesting conversation. I learned really a lot. Pádraic, thanks so much for your ideas, for your work, and also for the explanations you gave us today.
No, thanks a lot. I really enjoyed it. Thanks so much for inviting me on and giving me the chance to talk about this. And I hope that maybe some of the younger listeners or those that are thinking about how they might use their career will maybe be inspired to look at how they could contribute. And because really we need millions and millions of people working on this. It's the biggest challenge of our time, and potentially and probably the biggest challenge of our species to date is trying to come up with a way of living in an advanced and healthy civilization on a finite planet without destroying it.
Thank you. I think that was a perfect last word for our episode. Thank you so much, and have a good day.
Thank you. Thanks a lot. Bye-bye.